Okay. We are now doing lab 5. So what we're doing here is we are implementing a list. We are implementing a list. We could do it using a linked list the way we did it in lab 6, but here we're doing it using just arrays, rather blocks of memory that we are remaking. Okay. So so we start with Q1. We want int list.h. That's over here. Create this guy. We'll save it. Level 5. This would be int list.h. Okay. So we want something like this, and then we'll create int list.c, and we'll create a main. I'll also open the folder. What do we want to do here? So we want to say that we are so I did it in the lecture as well, right? But we want to make something like this, and we want to do a create list from data kind of thing first. So let's do that. So that we already had done in lecture. But to repeat, so what we're doing is we're setting int list, and we're saying the address of, and we're saying the int list we're malloking. We are then also malloking the data. So we're malloking a block of ints that's of this size. We then So this we this we do with memcpy here, which is similar to memmove. So what we're doing is we're saying copy this much data to here from here, and then we're setting the size and we're setting the capacity to be the same. So that's like this. I will now just create a test int list so that we are testing as we're going. Creating this. So let me change this so that it doesn't look like it's indices. And now, for now, I'll just print something. So I'll print this. So get list, I haven't defined yet. So what I'll do instead is I'll say list and then data at 1. That's the same. Okay. So let me do the configure tasks thing. Go here, change this to int list c and test int list c. And I'm now going to run it. And here we have the second element as 20. So that is what it is supposed to be. Okay, so the next task. So we actually need to have it implement everything else, and then we'll do list insert and list delete. So here. So let's do list append. So the basic issue here is that the data looks kind of like this, right? So there is this, and then there is like empty spaces, and then we're done in general. So in general, if there is space here, so if the capacity is small enough, is large enough, sorry, you can just append the element here and nothing changes. The problem is sometimes you run out of capacity. So if you run out of capacity, what you want to do is you want to say, okay, data used to be whatever it is, so the address of the 10, but now we want to copy it somewhere else where there is more capacity. So you want to do it with real. So you want to do it with realloc rather than something else because you want to copy all the existing data. Okay, so that we also did in lecture. So just do it quickly. So we're saying, okay, so if the size is the same as the capacity, we'll increase the capacity and we'll realloc and we'll put the new element here. So now let's say that we want to insert. So insert is called list insert, like this. So how would insert work? So let's say that the list is like this, and you want to insert an element over here. So that means that you want to take those guys and you want to move them to the right. So you can use memcpy in order to move chunks of memory, right? So you can say, I want to move data +1, and I want to move two integers. You can move them anywhere. The problem is that memcpy is not going to work, or is rather not going to have defined behavior if the location of the new block and the location of the old block overlap. So what you want to do rather is you want to say, okay, mem move, which does account for overlaps, and it works with overlaps as well. So you can, for example, move those guys one slot to the right like this. So, okay. So how can we do this? So the first thing we'll do is the same as this. So we'll check if the capacity is enough. If the capacity is not enough, we'll just increase it by 2. And then we'll say, okay, so go from the data at index +1 and move to there from data plus index. So what does this mean here? So if we are over here, what we want to do is we want to say, okay, so if this is address, so if this is address 50 and this is address 60, this is address 70 and this is address 80, what we are essentially wanting to say is copy the two elements from address 70 and 80 to address 80, 90. So that is what we're doing here. And the way we're doing it is we're saying list data plus index. So list data is the address of the first element, so 50 in this example. List data plus 2, for example, would be 70. And what we're saying is copy from address 70 to address 80 if each integer takes up 10, which it doesn't. So from address 70 to address 80, like this. And then we're saying copy this much. Once you've copied it, so essentially what you're doing is something like this. Now you can put the new element over here. It will be the new element. And that's exactly what we're doing over here. All right. Okay, let's try this. So we haven't yet done the print list. So let me do print list. Is it code here? We don't have one, so I'll just make one. Like this. So here it's going like just print this and then space. So it'll print the list. This. So I think what I want to do is I want to have commas as well. And I want to print this. It's too much. And I want to print something like this so that it prints over here. So that will print the last comma. So I'll go to sentence 1. And then I'm going to say if there is anything to print, then I'll print the last element. And at this point, I might as well just, well, actually no, because this should print regardless, even if it's an empty list. So it's like this. And I'll print the list. So let me just check that print list works. Okay, print list works. Let me try to insert. So I want to insert 25 at location 2. That seems reasonable. And then I'll print the list again. All right. So we inserted 25 at location 2, like so. All right. So now what we want to do is a different C file. So we want to name it intlist2.c. And now we want to increase the capacity by 1 at a time and shrink the capacity by a factor of 2 whenever it's possible. So that means when we delete. So, okay. So first of all, I'll also do a delete thing. So delete for now just moves the data from index +1 to index, right? So again, all this does is if you have a list that's like this and you want to delete this guy, then all this means is you just want to say, I'm moving this over here and I'm decreasing the size, right? So essentially say, okay, take this, cut this, and move this over here. That's going to be like this. And then I'm decreasing the size. I am not decreasing the capacity. So that's like this. Let me try this. So I'm deleting element 3, and I want to print the list again. And so here I inserted in 25, and then I wanted to delete element 3, and I got a list to be like this. So, okay, there's something on Discord. No. Okay. So now what we're asked to do is to have another int list 2, like so. And in int list 2, what we want to do is we want to decrease the capacity whenever possible and only increase the capacity by 1. So it's not really a big change. So here we're saying here, rather than multiplying by 2, we'll add 1. And whenever we delete, we want to also decrease the capacity, right? So here, like essentially what we want to say is the capacity is the same as the size, essentially, right? So here, what I want to do is I want to say, okay, so we decrease the size, so I also want to reallocate the data. So I'm going to say capacity decreased by 1, and I'm reallocating the data like this so that now the capacity is the new capacity rather than the old capacity. One issue, actually, no, there's no issue. So that's pretty much it. So for now, if I run this, nothing's changed because I'm still using the old int list. However, if I go to tasks.json and I say int list 2, I'm now going to be using the new functions from int list 2, which are, of course, the same. It's just the capacity management that changed, so the output is still the same. So that is lab 5. I'm going to take another 5-minute break, and I'll come back with lab